So if you just want to pay attention for a second, we'll look at two techniques that I saw while walking around. For 12a, some people use the remainder theorem. The remainder theorem says that if I plug in p of negative 3, I should get 0 if it's a factor. Well, what does it look like if I plug in p of negative 3? I'll have negative 3 cubed minus 2 times negative 3 squared plus a negative 3 minus 6. And if this is going to be a factor, our remainder theorem says this has to equal 0. So I'm going to get negative 27b minus 18 minus 9. Put those together, solve for b. 27 equals negative 27b, divide by negative 27. And we get b is equal to negative 1. So that's how we could solve this question using our factor theorem and our remainder theorem. Plug in the number, and because we want it to be a factor, we need it to equal 0. And then solving for that gives us b is equal to negative 1. Now, the other method that I saw people do was sort of a working backwards method. They set up their synthetic division. They said if I'm dividing by x plus 3, I'd have an x minus 3 here. And my coefficients are b, negative 2, 1, negative 6. And what do I know in the end? I know this has to be 0. Well, if that's 0, what's one number that I could fill in here? Well, this has to be 6. Well, if that's 6, what would go here? Negative 2. And if this is negative 2, this has to be negative 3. And if that's negative 3, this has to be 1. And if that's 1, this has to be 3. And if that's 3, this has to be negative 1. And how did we get that negative 1? By bringing b down. So this is sort of like working backwards. And in this case, I think it works just as well as using your factor theorem, remainder theorem. But when you get to part B, I would say one of these techniques is more difficult to work with than the other one. You can still make both of them work, but this is where just because you like one method over another, it's not necessarily good to completely disregard the other method and forget it and say I don't need to use it, because there are situations like 12b where the synthetic division one doesn't work as nicely.